going to talk about Chapter 4 and Chapter 5. All right. So tonight we're going to talk a lot about Layer 2 security, and in Chapter 4, and CBAC in Chapter 5. I'm going to actually try to get caught up by chapter, kind of dragging a little bit. There's not any practical application as far as GNS3 tonight, but what we will be doing is kind of setting the stage for a larger lecture on Tuesday with examples and a lot of GNS3. So I'm going to talk about Layer 2 security tonight, security features that are on switches, some things that you have to look out for in network design, dealing with spanning tree, port security, MAC address filters, etc. A lot of the security that I'm going to talk about switches from a design perspective is nothing necessarily that a bad guy or gal is going to do, a hacker is going to do, but it is one of those items where the network engineer messes up the network, or the network designer messes up the network because they either are ill-trained or uninformed, or let's just face it, just plain dumb. So, securing Layer 2. In this chapter, we're going to cover the practices, the theory, principles of hardening a Layer 2 switch at the port level. Layer 2 switching is becoming faster and faster and faster all the time. All right, when I started in this industry, 10 megabit Ethernet was blazing fast. Now it's like the slowest thing on the market. All right. We're getting into speeds of gigabit, 10 gigabit, 100 gigabit, 1,000 gigabit networks. All right, most of the latter fiber optic. But it's getting that fast. Okay? And Layer 2 switching is very important how we manage it and how we set it up for security. Because since those speeds are so fast, if an attack happens on a local area network, it can propagate at lightning speed. So the first thing that we want to look at is how Ethernet itself is set up and some of the inherent features of Ethernet and how we can combat them or how they can be used against us. The first thing we want to talk about is storm control. What storm control is the way that we manage or block broadcast storms. Broadcasts are all F destination frames in Ethernet. Okay, a MAC address is basically 12 characters in length. All right, either separated by colons every 2 characters or periods every 4 characters. And a broadcast is all Fs. F, 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 F. That designates a broadcast. What a broadcast does, or what it tells the system to do, is I want this frame to go to every station on the network. So what storm control does is it can help manage or quelch broadcast traffic. Broadcast storms can be caused by malicious activity or just simple malfunctioning equipment. Okay, some network chipsets that were, are made by manufacturers like Emulex or Broadcom. If they break or if components wear out, they can just start pumping out all F signals and cause a broadcast. All right. To combat this, the amount of broadcast traffic or time interval between the broadcast traffic can be configured. This is done with the following storm control commands. We're not going to go into that in too much depth. I wanted to bring that to light so you know that is a configuration feature on layer 2 switches. Protecting ports, or private VLANing, sometimes requires that not all traffic is sent between two hosts. You may isolate two hosts on the same VLAN with the use of protected ports. You must do this to both ports. Okay? So, for example, if I have a VLAN, alright, several PCs on that VLAN. For whatever reason, I have these two PCs. They can only talk to one another. I don't want them talking to anybody else. I can put that switch port protected on those two access ports, and only those two devices will talk to one another. Nobody else will talk to them. Okay. Now, private VLANs can also prevent inter-host communication. All right, providing a certain level of port security. You can only try this on access ports. Do not do this on trunk ports. Okay. Real quick, there are two types of ports. On switches. So, say we have two switches. Real quick review. Let's say these are in VLAN 100, these are in VLAN 200. Let's say that these are in 100, these are in 200, these are in 300. Okay? I have individual devices that are tied to them. PCs, printers, servers, whatever, right? Each one of these ports is an access port because it's tied to one single VLAN. Now, I need to tie both these switches together so that VLAN 200 can talk to VLAN 200, VLAN 100 can talk to VLAN 100. This is a trunk. Because I can configure multiple VLANs across it. I can configure multiple VLANs across it. If I don't configure this as a trunk, and these are both access ports, these ports take on the VLAN of what is configured on them. And only that VLAN. Okay? So setting up private VLANing comes into play, and it is very important when we talk about access ports across multiple switches. Okay?
Quick question, when you said the two types of ports for switches, are you saying access ports and trunk ports?
Correct. Alright. You only want to do private VLANing on access ports. You can't do it on trunk ports. There are three types of VLAN ports: promiscuous, isolated, and community. So, let's say I have devices in, PCs in VLAN 200. Right? And I only want these PCs in VLAN 200 to talk to one another. Alright? I only want this PC to talk to the router port. Okay? And I want this PC to talk to everybody. I can make these a community, this isolated, and this promiscuous. Depends on how you want to group things. Okay? Based on that security model, that security premise. Okay? So if I only had These are in a community, they're only going to talk to one another. If this is isolated and only needs to talk to its default gateway and nothing else, it's isolated. And this needs to talk to everybody, okay? It's promiscuous. Here's how you set that up.
I have another quick question for
Yep.
the last slide.
Sure.
You said isolated, you can only talk to the gateways, but on the slide, the last point, you said it can also talk to the promiscuous.
It can also talk to the promiscuous, yes.
Okay.
All right. Gateway, yeah, isolated is only going to talk to promiscuous or its gateway. My fault. Hence why the promiscuous will be able to talk to everybody. So I'm going to go over how that is set up in those next few slides. I'm going to skip over that. You can read that on your own. This is not going to be covered on the test of the lab, so I'm kind of, again, going to covering it because it is important, but I'm not going to go into it in depth. Port blocking. This feature blocks unwanted multicast and unicast traffic. Let's pause right there. What's unicast traffic? What's unicast traffic? I know you know, you sat in last class. One-to-one communication. All right? Host to host. Host to gateway. What's multicast traffic?
Sort of like promiscuous?
Huh?
Is it sort of like how we can talk to every
Groups.
group?
Groups. So if I'm in a multicast group, I'm talking to everybody in that multicast group. It kind of works like broadcasts, but in a more limited fashion. Okay? You can block multicast traffic and you can block unicast traffic by using the following commands. Be very careful with this one. If you block unicast traffic, you're going to break stuff really, really, really fast. You would only use this if that end device is only and solely participating in a multicast group. Nothing else. Port security. This is a very powerful and dynamic feature of iOS. It allows only a device with a registered MAC address to access that port. Now, this takes a lot of documentation, a lot of overhead, and a lot of patience to do and set up. Okay? And the reason you want to do this is to control the physical layer. So if you have a large organization, right, or if you have a community area, a high traffic area where people can plug in, you know, hotel lobby or a common area. All right, now wireless is we've gotten kind of away from this if we deploy wireless. But if you have certain MAC addresses that you tie to that port, only those MAC addresses are allowed to participate. Now, it doesn't stop me from trying to spoof a MAC address and guess I can manipulate things that way, but it makes things harder. Okay? And the security MAC-add and then the source MAC address is how you configure that on a per port basis. But it can be very administratively intensive because you have to keep tables and spreadsheets of MAC addresses, and it's for a small organization it's really good, really tight, but large organizations, no, it's a nightmare. A little bit more on port security, on how to configure it. And there's a couple of examples in Chapter 4. Now, access lists on switches use MAC level ACLs. I'm not going to spend a lot of time on this. They can be set up, and a lot of time while you set up a MAC access list is for access into the switched environment. Okay, now you have to know every last MAC address. It's hard to put in MAC ranges because you're going to have different vendors, different manufacturers' equipment on your network, right? If you are solely using Cisco equipment, you can set up a MAC level access list only for Cisco's first set identifier of their MAC address. I really don't find that very much. Where I find MAC filters is on access points. Okay? On access points that are not controlled by wireless controllers. Okay? In small networks, home networks, works great. I have one at my house. I have 10, 12 devices in my home. Not that big of a deal. Not that big of a deal to administrate. So I was telling last class, I had one customer that when I started with Nick, their entire school district had an ACL-based access list on all of their access points. The lady administrating this, she spent the first 3 hours of her day, somebody needed access to the network, all she did was go in there and administrate ACLs. It's painful. Absolutely just really disorganized. I kind of scratched my head and wow. And all I really have to do is spoof a MAC address and I'm on your network anyway. When I told her that, I think she was about ready to come to church. Get around that. Put in a centralized control mechanism, a wireless controller. You can still do MAC filtering, but you can push it out to all the ACLs a lot quicker. And you can do a lot more on the security side of the house as well. All right? Again, MAC-based ACLs, great for a small environment, does not scale well. That's your big takeaway. Spanning tree. Now, spanning tree uses BPDU, or Bridge Protocol Data Unit Guard. And this can disable a switchboard from participating in spanning tree. Let's back up a second and talk about spanning tree real quick. What does spanning tree do? What does spanning tree do, anybody? What?
Prevent the looping in the switch.
Prevents loop at layer 2. Absolutely correct. Good job. So, I have a network. I have an MDF, main distribution frame, a few IDFs. What BBDU guard will do is, if I have other things going across here and I get really crazy with my network and I start linking things together. Alright, what spanning tree will do is it will work with BPDU guard and help block different links when they come up. Alright, spanning tree will do this by default, but BPDU guard will help you manage this better. So if I want to say block these two with BPDU guard so I can use this one as my default, I can allow myself to do that. Why? I don't know, but you can manipulate spanning tree in this fashion, okay, on an administrative basis. All right, and in essence, the switch part will never go into the blocking state and will remain on constantly ignore spanning tree instructions to begin blocking. So it will pin up the connection. You have to be very, very, very careful with this, because if you don't use it right, you'll break your network. Okay? Root guard. All right? What root guard will do is it will allow the election of a switch to be the root bridge, or set a root switch in spanning tree. Now, one of the things, let me back up real quick with BPDU guard. If you don't set this up correctly, right? Had a teacher at a middle school who thought he was Joe Engineer. He was, has no knowledge of networking. He thought that if I bring my own switch in and my own Ethernet cable and I plug in all these three, instead of having 100 megabit, I'll get 300 megabits of bandwidth. All he did was create a loop for himself, right? When this happens, you see CPU and memory utilization percentage spike up. Fortunately, in the school this happened at, we were monitoring it. I started getting alerts because he came in on a Saturday and thought he was going to be really, really, really cool and do all this and make it really faster for his students, and he basically brought the entire middle school down to his knees. Dispatched tech out there on the next following Monday, found the problem. He found it in like 5 minutes, disconnected everything, brought everything back into alignment, if you will. And he spent more time explaining to this teacher why that was a bad idea than he did actually fixing the problem. That's all right. Oops, back up here. Root guard is where we control the election of your root bridge. Again, more administrative in nature, but from a security standpoint, it can help you defeat a denial of service attack. So a lot of times in a good architected collapsed backbone environment, you're going to have your core, distribution, and access layer network, or access layers. All right? Distribution, core, access. All right? In a Cisco environment, a perfect Cisco world, this will be a 6500 series switch, maybe a Nexus 7000. This will be a 4500 or a Nexus 5000. And these will typically be 35 or 3600s or Nexus 1000. Right?
We don't have to know that.
Huh?
We don't have to know that.
No. I'm just giving an example. The root guard piece is basically where you can go in and configure spanning tree guard root on each of these switches, and you can turn it off on them or default it to a low setting and a high setting on your core, and this becomes your root bridge. This controls spanning tree. It controls if you have, additional links and mesh for redundancy, which is good. Right, which is good. It controls which ports are blocked, which ports become the root port, the designated port, etc. All right? Yeah?
Can you repeat that one more time?
What root guard does? Okay, it will elect the root bridge, or it will allow you to set the root bridge, and then that root bridge, if you have multiple paths through the network, it will tell spanning tree, lock this port, allow this port, use this port. It'll help you set your root ports, your designated ports on each individual switch. Okay? When you have a spanning tree topology change, that can become very processor intensive. All right? Very processor intensive. So you want to have a higher level switch that's making that decision. Okay, a 6500 in this case. All right? Now if you have another Cisco switch, because this is proprietary to Cisco, it comes in, or is it a Huawei switch, the Chinese company that makes, is it Huawei that they make switches?
Yeah.
Yeah, that's based on Cisco iOS that was stolen. All right? They can do that too. You have a lower end switch, say a 2940, and by whatever reason you don't have root guard set up correctly, or some way this gets elected as your root bridge, a topology change happens, this guy can't keep up. Case in point, I had an IT director from a municipality, decent sized municipality, okay, not LA, but you know, a nice sized city, call me, swore up and down he was getting hacked. Our city's under attack, our services are going out, we can't get out to the internet, you know, we can't have people talk from, you know, the fire stations to the city hall to this, to that, to the other. Help. I'm like, wow, that's pretty serious. So, grabbed one of my CCI securities, went out to this city, and started looking at their traffic and everything else, and right away, we knew it wasn't an attack. We just tell by looking at spanning tree. We saw all these topologies changes happening, and we know, okay, there's a loop somewhere. That was our first thought. You know, okay, so we practically went around to every last IDF in the entire city looking for a loop somewhere. Over the course of a weekend, we finally found a little 2940 switch at the New City Pool in an IDF that was configured as the root bridge for the entire city. Did that, everything came back. Because this thing was just like, it's activity light, which is solid green. All the traffic that was going through it, yeah.
So for it to do that, was that just default setting that was on that switch, or?
It was a switch that a consultant had put in, and he or she did not know what in the world they were doing at all. So again, sometimes it comes down to, if you don't know what you're doing, you need to research it or ask for help or call TAC or something. Okay? Don't make assumptions. Assumptions bring down networks. Bringing down networks is bad. Bringing down networks will cost you your job. I can guarantee you that consultant never got asked back to that city. Ether channel guard is used to overcome configuration mismatches in spanning tree. Alright? So what Ether channel guard is you can have multiple links between two switches. Right? Like I had with that example where that teacher thought he was going to be really cool and get 300 megabits. You can do that. It's called Ether channel. Okay? So let's say that I have 2 gigabit connections here. I can combine them in an Ether channel and get a 2 gigabit connection. Absolutely. Okay? And I can make sure that that works with each Ether channel guard. Okay? To ensure that any type of misconfiguration between the two switches does not occur. And finally, loop guard. It helps prevent spanning tree loops by disabling root ports, alternative ports, and alternative ports from becoming designated ports. Now, it's really important to understand that root ports, all right, and alternative ports, which is if a root port goes down, the alternative port becomes a root port. All right, they control the flow of traffic, and a designated port is basically a port that is a designated port that you cannot block. It cannot go into blocking state. Okay, so if root ports and alternative ports become a designated port, you can have loops injected into your environment. Loop guard will prevent that. Let's talk about DHCP and DHCP spoofing defense. Alright? This prevents rogue DHCP servers from entering the network for the purposes of gaining access. One of the ways that bad guys like to get into networks is if they can gain physical control. Alright? They may not be able to get a DHCP address. Or, even better, they can inject a DHCP server into the network so that your clients can get a DHCP address from them instead of somebody else. Or they can bridge the network in the case of a wireless network. I've seen this done before, where you do this. I have my laptop. I have my wireless card. I set up my wireless card as an AP. Right? I run DHCPD, say in Linux. I then wire to the network. I can allow other laptops or wireless devices to connect to me instead of the normal AP, and I can hand them out DHCP addresses. Do a little bit of routing on the back end, and instead of them going through the AP to get onto the network, they go through my laptop. Now, why would I want to do that? Why would I want to do that? What did we do last class? What did I show you in GNS3? Wireshark. I can look at packets. And if I can sniff packets, what can I do? I can get all your information. Right? I can get all your information. Alright, you've got to be very, very, very leery of this from a wireless perspective. This is one of the reasons I never, ever, ever attach to a unguarded network, a non-secure network. I want to have encryption, even if it's web encryption. Like, at least I got something. Right? Okay? This has happened on this campus. I've caught people doing this on this campus. Okay? I've caught my former students doing this on this campus. Anyway, DHCP snooping will help fight this because it won't allow DHCP to propagate the network unless it's from specific ports on specific switches. Yep.
In that scenario, has it totally, I guess, just disabled the original DHCP server so that it's not even aware that something else is using that address?
Right.
Okay. Is there something that, well, I guess if they've already got control of this thing, but I'm going to say, is there a way that if they left it running, it would know that it didn't hand out an address that someone talked to it?
Basically, once you cable up here, right? DHCP address, DHCP could happen through here, right? But with DHCP snooping, if I'm not coming from a specific IP address, I'm not going to allow it, okay? So even when these guys, now there is one other way you can get around this from a hacking perspective and fight DHCP snooping, and that's if you put NAT on this thing. If you NAT and you have this completely isolated and is seen as coming from that, that's not going to work. Okay, so that, I think that's where you're driving with that. So yeah, that won't work. Okay?
So for NAT means that laptop's RJ45 acting as a router.
Right. Right. Okay. But if it's just acting as a bridge, all right? If it's just acting as a bridge, it will, the network will see this DHCP service and it'll crush it. So for every type of defense out there, you know, the bad guys and gals are looking for ways around it. Let's go into CBAC. Now, this is very important because this is a lot of what we're going to do in Lab 2. This is a lot of what we're going to do in Lab 2, especially with the iOS firewall feature set. And a little bit of what we're going to do in Lab 3 with IP inspect. So routers as firewalls. Yes, routers can be configured in a way to act as a firewall, a VPN appliance, and even as what we call a poor man's intrusion detection system. It has stateful packet inspection, which we're going to talk about here a little bit later, and that's a key piece of the lecture tonight. It will have context-based access control, intrusion prevention, and intrusion detection systems, an authentication proxy, which we're not going to go into too deeply, port to application proxy, which again we're not going to go into too deeply, NAT and PAT, which we will talk about, and we're going to touch on zone-based policy firewall, which is nothing more than a virtual firewall or multiple routers within one router. VMware for routing, if you will. So the basic definition of a stateful firewall is that it is going to inspect traffic and keep the established states of connections up and running. All right, the key concept that I want you to grasp tonight is state. All right, after a TCP three-way handshake and access through a firewall happens, or outbound access through a firewall happens, that state is what we call established. Now we'll go into that a little bit deeper here when we get into NAT and PAT. Okay, and that is one concept that you have to grasp because it's very important from a defensive posture standpoint. Okay? They can monitor traffic through syslog, okay, or through third-party application. It does network address translation as well as port address translation, which I'll go through here momentarily. Okay, and it's very important to understand how that works. But before we get into that, I want to talk a little bit about the method of attacks. The bad guys are not going to know what's on your network initially, so they have to do some form of reconnaissance. That is through port scans, ping sweeps. They got to find out what's on your network, what applications are open through different ports that you have open on your network. Then they can look at spoofing an IP address, doing a man-in-the-middle attack. They can look at what applications you are running, try to figure out what vulnerabilities are in that application, and even do denial of service attacks. Denial of service attacks, kind of old school, although they're making more and more of a comeback, especially with the lulsec and anonymous groups, okay, the hacktivists that are out there. But the application level attacks are what worry me the most, okay? Denial of service attacks, not a whole lot I can do about it, okay, other than contact my ISP and try to filter that traffic upstream. This is nothing more than who has enough bandwidth or who has the bigger amount of bandwidth to overcome things. This is what you worry about, because application level attacks are how hackers get into systems and gain information, pull out personal identification information, account information, etc. Now, at the perimeter, your firewall is your key piece that blocks traffic. All right? And there are different types of things that you have to set up in a firewall. Okay, basic router security, which is what we did in Lab 1. Okay? We want to make sure that that device is nicely locked down from remote access, for example. It will do packet filtering. Packet filtering is basically set up to look at source, destination, address, source, destination, port, and protocol. Okay, and we can filter based on that level of information. And then we have stateful inspection firewalls, which we're going to talk about tonight with the IP inspect feature. And here's where we need to get into understanding what state means. Let's take a very simple network, for example. I have a network, I need to connect to the internet. I have everything addressed with a RFC 1918 address, right? So all my PCs are .127 through, actually, .129 through 254. Right? And I have 3 servers, a web server, a mail server, and a DNS server, .80, 25, and 53 respectively. Okay, that's my network. My gateway stop. Okay? I need to get out on the internet. Well, in order to get out on the internet, I need to have some sort of public IP address, right? Right? So, my ISP gives me a 202.101.18.0/29 block. Well, if I had a full Class C network, this wouldn't be a problem. What happened last year that was really, really, really bad? What happened with IPv4 address space?
Run out.
We ran out, right? Okay. Now, I can go to IPv6, yeah, no problem. Okay, not a lot of US-based companies are moving to IPv6. Okay, I hate to say this, we don't have a really good set of strong network engineers in this country, and Europe and Japan are kind of moving past us. But we can still get smaller blocks of addresses from our ISP. What we have to do is set up NAT or PAT. NAT is 1-for-1. PAT is many to 1. Okay? So for example, I want to give usually my servers, the things that I have services on, their own IP. Right? So I can put in a NAT statement in my firewall, for example, where 202.101.18.2 equals 192.168.0.80. That would be a static statement. Now, I have 1, 2, 3, 4, 5 PCs. 1, 2, 3, 4, 5, 6, 7, 8. I only got 6 public IP addresses. I'm using 1 on the outside of my router. I don't have enough IP addresses. Do these 3 get internet access and these 2 don't? That's not very practical. So I can use port address translation or a many-to-one scope where all these PCs translate through one IP address. For example, the IP address that's on the outside interface of my router. Well, what the router will do is it will build a table so that 192.168.0.129 is going to get assigned a higher level port number, TCP port number. Okay? So that anything that goes out is tracked via a port number to its end connection. When traffic comes back, it knows which individual host to send it to. So when traffic goes out, gets established, okay, if it's TCP, if it's UDP, I don't care, right? It's fire and forget, one way, who cares, right? But if it's TCP and it has to come back and make that handshake, all right, it'll track it within the NAT table, okay? In the same table, static entries are 1-for-1 as well, but we don't have to worry about it because they're 1-for-1. Doesn't matter what traffic is. But PAT entries, you can have several PAT entries for several end destinations for one IP address. They'll just have a different port number each time. Okay? But once that traffic is gone through the network and we establish it, say we just go to Google and do a Google search. Alright? That traffic, once it's outside the firewall and that handshake happens, that's called an established connection. let's say we have a firewall rule set. Okay? We have to open up port 80 for outside vendors or the public to see our website. We have to open up TCP 25 for mail to come in, for mail servers. We may have to open up TCP 53 for zone transfers on DNS. Okay? Now, regular UDP traffic, okay, just for lookups, that's fine. But to keep zone transfers and updates, we have to open up TCP 53. Anytime that has to come in from anywhere on the network, that's an established connection. Okay? Now, this is more controllable because we can write access lists on the outside and point it and see it. We can really kind of shield, the perimeter defense in that fashion. Here's where you run into trouble. Okay? And this is where the IP inspect feature in CBAC is so handy. Alright? We are so busy kind of shielding ourselves from the internet, we don't see what's going on behind us. So if users on the network go out to websites, right, or they click on a link in an email and it starts a connection, we may not be filtering that. And that's an easy way, or if I can get into an established connection in some fashion, I have a way into your environment. Okay? If I can do a man-in-the-middle attack, for example. And once I do that, I'm around your perimeter defense. So, what the premise of IP inspect and a CBAC perimeter router is to watch those established connections, look at what they're doing, and log them. Okay, so we can create an audit trail. Okay, and it can be a key piece in network forensics. So, with the iOS feature set, security-specific options for iOS software can be invoked. Alright, and it's a version of Cisco iOS with an add-on feature. That's also can be a little bit more affordable than your typical ASA if you have to spend $5,000+ on a firewall, dedicated firewall. It's been around since iOS 11.2. It gives you the ability to configure a router in a fairly secure fashion using regular access control lists. And it provides a little bit more granular packet filtering at layers 2, 3, and 4. Now, it does traffic filtering, traffic inspection, alerts and audit trails, which is very important, and a limited amount of intrusion detection. Now, on the filtering side, that's the easy part. Context-based access control intelligently filter TCP and UDP packets. Without CBAC, traffic filtering is limited to access list implementations that examine packets at the network layer. CBAC examines not only network and transport layer info, but also application layer information such as FTP connection info, SMTP connection information, HTTP connection information, etc. And CBAC inspects traffic that travels through the firewall to discover and manage state information, establishment information, for TCP and UDP sessions. This creates temporary openings in the firewall. Access control lists to allow return traffic originating from within the internal network. That helps to thwart man-in-the-middle attacks. And prevents SYN flooding and some DOS attacks. Okay? Such as a half-open synchronization attack. Alright, alerts and audit trails. It'll generate real-time alerts, and those alerts can be managed, okay, depending on where you want to send them. You can send them to a syslog server, you can send them to a third-party application server that will call you, page you, send you an email, I don't know, throw out a carrier pigeon or something. It's, you know, but it can be leveraged by other applications. All right, syslog is the main application that will track all network transactions. Okay, the intrusion detection piece will look at the top 59 or most common attack signatures that are out there. All right, and look at the patterns for misuse. Now, these signatures are only going to look at the information in your IP and TCP or UDP header. All right, they will not do deep packet inspection or what we call holistic inspection. Okay, they don't look for patterns within the data of the payload. All right. Now, if you want that, there are other more robust systems that will do that. This is very basic, okay? But it's better than nothing. And for a small network, it's great. Okay, kind of talked about this already with the previous discussion. How do we configure it? Well, a common setup is to configure the ACL and CBAC inbound on the external interface of an internet router to protect a private network from harmful traffic. Okay, that's that shield I talked about. Your main concern is to allow in only return traffic from sessions initiated internally. Okay, or that established traffic. This is kind of how you set that up. You want to deny TCP any, deny UDP any. Okay, inbound. All right, on your outside interface. So this would be, for example, this interface. Now keep in mind that CBAC does not inspect ICMP traffic, it only does TCP and UDP. And you'll need to add inbound ACLs to allow ICMP into your environment, if you want it. Now sometimes you will want that because you may want to have, echo traffic or echo return traffic for ping, trace route, unreachables come in. So up to here we've shown you how to configure entries for the extended access list and apply that configuration to the inbound traffic on the external interface. The ACL has entries to block all the traffic we want to inspect with CBAC, rather than modify the timeouts. Now, one thing you have to do is, if you do have traffic that's coming into specific services, on that extended access list, you have to allow it in there as well. So in the previous example, I denied TCP and UDP. All right, if I did not have permits, it's going to get dropped. So you have to make sure you have the permit statements in there as well, if you have services behind that firewall. That's kind of what I was getting to. Now, to put into the inspection rule command, it's IP inspect, name, inspection name, protocol, alert on or off, audit trail on or off, and timeouts. Now, I'm not going to go into the timeout piece. Okay, I don't care. Keep that default when you see this, and you're going to see a couple of slides here in a minute that are very, very important. Mark them, check them, write in your notes, hey, keep this around. I'm going to see this later, as you will. But this is a global config command, and it requires that you specify a name, protocol, alert setting, etc. Here's an example of that. IP inspect, name, my firewall, this is arbitrary. Protocol, TCP, alerting on, audit trail on. So I'm going to inspect TCP. So we've named the rule my firewall, specified TCP as the protocol to inspect, and activated the alert and auditing options. Okay? This requires that you have a syslog server somewhere, and you have logging set up in your router. Okay, I do recommend using auditing for logging all firewall activity, regardless of whether you're using an iOS firewall, an ASA, what have you. Because it's great to have a firewall. It's even better to have a firewall that will give you additional information. as to, oh, who's trying to attack me? Where do I see malicious traffic coming from? Am I a target by the North Koreans, the Chinese, the Russians? Why did the Russians went into my network? You know? All right. On that same interface, you want to put this inspection outbound. So you inspect outbound traffic. Notice that we've applied the inspection rule outbound on it, the external interface, and it will track sessions started internally and heading out through the external interface bound for the internet or some other external network. If you have difficulty during CBAC configuration, you can disable and reset all related settings using the following global mode command. This won't remove your extended access list configured on the outside interface. If you turn off inspection, keep in mind that it will most likely halt all traffic entering your private network because the access list is filtering most, if not all, inbound traffic at the external interface. So turning off inspection is very simple, but it will break things if you still have it applied to the interface. Okay, so be careful. If you take it out globally, make sure you take it out on the interface as well. Otherwise it will break stuff, and that's bad. When people lose internet, they lose their minds. Anybody who's ever worked in IT knows that. The command will remove all the inspection information from the configuration, including the filter statements and command line that applies to the interface. Okay? That even happens at home. I lose internet at home, it seems like time stops. My kids don't know what the heck to do. The Xbox don't work, Dad! That's because the internet's out. Play like, you know, go get some sunshine. You're too white. You're too pale. Now that the basic configuration details are out of the way, let's look at an example of a configuration. And with the ACLs and CBAC inspection activated, a generic inspection of UDP and TCP, an application inspection for HTTP, SMTP, and FTP is set up as such. These following slides you need to write down, mark, check, circle, make notes. Put in there for when you have a test. You need to come back to this. You might not need all of it, but you will definitely pull out pieces and parts of it. So, here's where we set up the name of the inspection list, the protocol, TCP and UDP, whether we're going to turn on alerting and audit trail, which we do both. Okay, we're going to inspect HTTP, SMTP, and FTP. Okay, we apply it to the external interface. Access list 105, deny, deny, permit, 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 permit. This is all ICMP that we permit. Now, again, going back, if we need to permit specific services, they would go before those deny statements on under TCP and UDP. They have to. Because it goes in sequence. It goes in sequence. So, if the packet that comes in is TCP, it gets dropped. If it comes in as UDP, it gets dropped. But if we have access list rules before those two that permit specifics, would be allowed. They will be allowed. And then these are different permits for ICMP, for example. All right, that kind of finishes up the ICMP, and it'll deny any other type of ICMP flags. Then you apply it to the inbound interface. In this case, for example, we'd be applying it right here. Okay, and then we would put in IP inspect my firewall out. What inspection is going to do is if I have traffic that goes outbound from my PCs, and it's established, that connection coming back in is going to be allowed. It's going to be allowed, regardless of what I have up there on that access list. The CBAC configuration will allow only limited ICMP information with those access list rules that we saw. The inspection rule filter 1 will allow internal users to start outbound World Wide Web sessions via HTTP and track the sessions opening return points in the static extended access list. This is also true for FTP and SMTP. Okay? Okay. To change inspection rules, you can easily add or delete them one at a time. If at any point you want to check the configuration, you can simply do the show IP inspect all, and it will bring up details. The all parameter will display information such as current configuration of inspection as well as current sessions traversing the firewall, which is very important. Okay, you can look at your state information from individual PCs. Great if you're running a small network and you got about 5, 6, 7, 8, 20 PCs. If you're running a huge network, you need to find some automated tools that will help you manage that.
If you show your configuration for the entire router, will it show the inspection configuration on there?
It will show the inspection configuration. It will not show you the state information, the current state information running through the firewall. That's where you have to do the show IP inspect all. It will give you that information as a snapshot in time. Okay? Simply installing the iOS firewall software does not fully ensure a secure network. The router and CBAC must be configured properly to secure the private network from unwanted access. And with this in mind, you will want to apply other well-known protections to the firewall. Among these are broadcast protections, anti-spoofing measures, and here's just a couple of examples. Okay? On the interface, no IP directed broadcast, no ICMP redirect, no IP redirect. Globally, no service finger, no CDP run. Alright? And no IP source route on your interface. Okay? That will prevent typical malformed packets from being allowed through the receive buffer on the interface. Okay? Because with the packet generator, I can specifically formulate IP packets for my own purposes. When we get later on in towards Lab 5 and you start working with Metasploit and Armitage, that does that on the fly for you. It's already pre-coded, if you will. Okay? But that's all it's doing. The prescripts that are in Metasploit is nothing more than an automated packet generator that pre-programs different flags within the TCP, UDP, or IDP, or ICMP, or IP header. All right. Don't consider this to be a complete list of precautions. This is merely a sample of the types of settings to implement for a secure network environment. Check the support website, check at Cisco. Be sure to look at other commonly known websites through the Department of Homeland Security, NIST, trying to think here. Carnegie Mellon has a great website. Their cert center is phenomenal. But you need to constantly stay up on vulnerabilities. Not just to infrastructure equipment, but also to operating systems as well. Okay? Don't think that once you're done with this class and you go out into the field, you know all there is. No. Guess what? Stuff is going to change tomorrow, and you need to stay on top of it. Summarizing, although the iOS firewall provides a higher level of security than the standard access list approach that you can put in, like other firewalls, it shouldn't be considered invulnerable. A determined hacker may be able to find holes in the most secure systems. I've demonstrated a strong security feature of CBAC, but you may want to consider a dual firewall approach if your security needs are in high demand. What hackers will try to do sometimes is if they see a firewall, they will either try to breach that firewall, knock that firewall out momentarily, bypass that firewall. If you have a second firewall in parallel with it, if that first firewall goes down, the second firewall will maintain the security while the primary firewall recovers. It's called a failover system. Some of the advanced features of iOS, you can do HTTP inspection and email inspection. It's limited, it's better than nothing. You set that up with IP inspect name, whatever you're going to name it, and you can do SMTP or ESMTP. You can reference that in the CBAC section of your book. You can do a firewall ACL bypass. So you can tell the certain IPs that, oh, you know what, I trust you. You can bypass my firewall feature set. Why you would want to do that, I don't know, but you could. Transparent iOS firewall at layer 2. Your router will then act as a bridge instead of a router. Okay? Same thing can be done in an ASA called transparent mode. Okay? Or what we call a stealth firewall, or a bump on the wire, because you can't see it. If you can't see it, it becomes very hard to knock out. And then there's virtual reassembly for both frame relay and MPLS. It's a little bit of an advanced topic that we're not going to go into. Inspection of router generated traffic. You can inspect traffic that is generated by your router. Now, what would that be? Could be dynamic routing protocol traffic. Could be traffic that is in response to queries on like your HTTP engine if you have to run your web engine. Zone-based policy firewall, or ZFW. This is router virtualization. I'm not going to go very deeply into it. There's a lengthy section on how to set this up. The thing that I tell clients and students alike is if you have to go and you have to virtualize your router and make multiple routers within a single routing device, all right, this is dozens of lines of code. In the ASA firewall, it's 2. Buy a firewall. It's easier to manage. It's worth the money. Okay? But it does have limited URL filtering and DOS mitigation. Okay? With the zone-based policy, you have to define your zones, define the class, build class maps. You have to do a lot of object-oriented programming. Define a policy map to apply the action to the traffic in a class map. Apply a policy map to a zone pair. Assign interfaces to the zones. It's a lot of programming. Okay? In the ASA, security level 50. Security level 20. Okay? That defines your zones and your trust between interfaces. You're done. Couple of notes, and I'm done. And I still got done 30 minutes before the last class. You guys don't ever ask any questions.
You're welcome.
Except for the gentleman in the back. Thank you very much. Any questions? You guys are just tired. It's late. I understand. Okay, I get it. You're okay. Last but not least, let's go over Lab 2. We'll go over Lab 2 a little bit more in depth on Tuesday. But in general, instead of 1 router, we're going to set up 3. Yay! Okay, these are the switches in GNS3 that you can set up. You connect everything into them. create a network, OSPF like we did before, except you're going to have two areas, not one area. And you're going to have EIGRP. The trick here is you're going to have to do some redistribution of routing protocols within R2. I'll go over that on Tuesday. All right? You have two networks. You have a workstation network and a server network. Okay? This would be your inside network basically. This would basically be like a demilitarized zone or DMZ. Okay? Dot 4 is going to be an Active Directory server that you're going to make in a VM. So if you want to work ahead, all right, or if you have your VM from CIS 347 that we did in Lab 4 in that class, you can pull that sucker up and use it for this lab. Give you a little bit of a leg up and save you some time. Otherwise, you got to build a Windows 2003 server. Oh yeah, I know. Like we haven't done that before. All right. So IP the routers according to the diagram. Ensure that you give the proper host name. Very important that you read through this. It's a couple of steps that I try to trip you up a little bit. Okay. So it's very important you read through it before you just start plugging away. Create the routing protocol domains according to topology. I'll talk a little bit about that more on Tuesday. Block any routing of RFC, that should be 1918, not 1921, 1918 networks. Read number 4. Before you start IP addressing everything, I change your subnet on you from a /25 to a /29. I will be looking at your subnet masks to see that you got number 4 correct. Create NAT as follows. Now on number 5, you can see that you have all these servers on the 192.168.50 network. You need to NAT them, statically NAT them, to these public IPs. Here's the trick of question number 5. You've got to figure out which router to do that on. R1, R2, or R3. Here's a hint. There's no one right answer. You can do this a couple of different ways. Alright? Either way is correct. So if you're working in your study groups, before you start tearing each other apart and arguing, no, you should do it this way, no, you should do it this way, you should do it, no. There's a couple different ways you can do it. Alright? Create and overload a port address translation and tie that to R1 for your workstations on 172.21.0.24. That's obviously your PAT is going to go here on R1. And you're going to tie it to that interface. And this can be an Ethernet interface. You don't have to put a cloud in there. As long as you IP this, that's all I'm looking for. All right, like I said, number 7, create a DHCP pool on R3 for that network, and you're going to exclude 1 through 25. 192.168.50.4 is your Active Directory server with the following credentials. Your administrator needs to have a password to change me. Create an ACS box on 50.10 and tie it to your AD. Okay? A couple different ways you can do this. You can create 2 VMs, or honestly, if you create 1 VM and have it all on one box, I'll show you how to do that on Tuesday. I'm gonna change up this so it's a little bit more clear before Tuesday. I apologize for that. You'll create an account in your AD box called John Doe. See, all you do is create a user. Now, you're going to use AAA commands to ensure that R1, R2, and R3 authenticate to the ACS server so that when John Doe tries to log into them, it works. Create an access list on R1 Remember that you natted previously. Right here. And set up all these rules in your ACL. 26 rules. Not that bad. Now, I do need a screen, along with your config files of R1, R2, and R3, I do need to have some screenshots of your ACS server. Okay? In that VM. Seeing how that you have that set up. Okay? And last but not least, you're going to set up OSPF to do area authentication with MD5, a key of Cisco, a shared key of Cisco, so that R1, R2, and R3 send all of their OSPF traffic, all their multicast traffic, okay, all their area information encrypted. That's very important when you get into network security of dynamic routing protocols, because if I can guess your network and I can plug in somewhere and I can participate in your dynamic routing protocol and you're not authenticating in any way, shape, or form, I can get your routing table. If I can get your routing table, I can corrupt your routing table. If I can corrupt your routing table, I can crush your network. It's very important. And this is one of the things that I see a lot of in large networks. They don't do any form of dynamic routing protocol encryption at all. It's a key concept that you need to have for network security, okay, to be effective. All right? Case in point, I have a couple of engineers. I'm really going to tout graduates of Cal Poly here. A couple of network engineers where I work. And I heard them complain and moan and groan and whine and gripe about this one customer. How difficult this customer was, what a pain in the butt this customer was. And once, as the support manager, I got the information from the account manager, and I talked to this customer. And then I found out what he was doing, and all he was doing was had a really good secure practice. He had a really tight VPN policy. He didn't allow anybody into his network that didn't need to be into his network. Right? He was just practicing good security. I can work with that. That's not a problem. You know? You don't want to discourage that. You don't. Okay? You want to work with it, not against it, not around it. Okay? Once I had found this out, I kind of took these other two engineers that were kind of being a problem off of that project. And I have two Cal Poly alums that work for me. I put them on it. They got it. They worked with the customer and they worked through the issues. Right? And they worked through the problem. Right? They carried themselves in a professional manner. And you know, they understood the reason behind this customer's security phobias, I guess you would say. Because I carry the same phobias, so we got along really well. All right, so I'm going to leave you with that tonight. We'll go in depth more so on Tuesday, Lab 2. You guys enjoying the class?
Yep.
Is it good? It's a little fast, a little challenging. Good. Life's challenging. Get used to it, guys, because I tell you what,